This video is on solving linear systems of equations by elimination. Feel free to pause this video if you have to take notes or if you need more time to process the information. And before watching this particular video, make sure that you've already seen the videos on solving systems of linear equations by graphing and by substitution. All right, so let's go ahead and get started. Excuse me. All right, so in order to solve by elimination, or a method that we call elimination, there's a few things that you need to understand. So let me go ahead and go over those really quickly. Let's say I've got a situation where two quantities are equal, A and B. As long as I do whatever I do to one side of the equation, I do the exact same thing to the other side of the equation. It balances out, and the left side stays equal to the right side. So if I add 7 to the left and I add 7 to the right, then it's okay, equal. So one way of writing that, I can say that 7 equals 7 right below it. And if I add the equations together vertically, the left side is A plus 7, and the right side is B plus 7. A and B were equal to begin with. And as long as I add the exact same quantity to the left and the right side, which I did, then my result is also going to be a balanced equation. All right. And I can extend that by, let's say, setting two other quantities equal to one another, like C equals D. And again, if I just combine these two equations into one equation, by adding vertically, I can say A plus C is equal to B plus D. And again, that's going to be true because A and B were equal to begin with. And as long as whatever I added to the left side of the equation is the same value as the equation, or what I added to the right side of the equation, then I end up with this balanced equation. Should still be true, logically. Okay? The other thing that we need to be aware of, that we already know but we want to make sure that we keep in mind, is if I have something like 3 plus 4 equals 7, and I decide that I want to change the middle number, let's say. It doesn't really matter which number we're changing, but let's just say I'm changing the middle number, and I want it to be 2 times bigger. Well, I can't just multiply the middle number by 2 and expect the entire equation to be balanced. I need to multiply everything by 2. It's not just multiplying part of the side, it's multiplying the entire side by 2. And if I multiply one side by 2, I have to multiply the other side by 2. So let's do that. 2 times 3, 2 times 4, 2 times 7. I can do something like this. This gives me 6 plus 8 equals 14. The equation remains balanced. It is saying something slightly different, but proportionately, everything is double the size because I multiplied everything by 2. Everything on the left, everything on the right. We're going to use those concepts to solve our system by elimination. And we're going to start off by noticing that if I simply just add these two equations together vertically, I really don't get much out of it. I'll end up with 22 on the right-hand side. And on the left-hand side, 2x plus x gives me 3x, negative 3y, and positive y give me negative 2y. I really don't get any closer to a solution. What would be great is if I had added the two equations together, that one of my variables canceled each other out and just went away completely. Then I would be able to solve for the remaining variable. And there's a potential for that to happen with the variable y. Because the variable y appears as a positive number on the top or on the bottom, and a negative number on the top. So if only the bottom number were a positive 3y instead of a negative 3y, then I would be in a position to be able to solve this system of linear equations. We can make that happen. But again, remember, we cannot multiply just the middle number by 3. You have to multiply every part of the left side of the equation by 3, and then you have to multiply the right side of the equation by 3. So let's do that. I'm going to change this to 3 times x plus 3 times y is equal to 3 times 4. So 3x plus 3y is equal to 12. Multiplying the left side by 3, multiplying the right side by 3. I'm just going to rewrite the top equation right above this one. That is 2x minus 3y equals 18. And now I'm going to go ahead and combine them. And when I combine them vertically, 2x plus 3x give me 5x. But notice that because of my setup, negative 3y and positive 3y cancel each other out. I've eliminated one of my variables. That's great, because now I've got one variable left. I know I'm going to end up with one equation, and that's going to be solvable. 18 plus 12 on the other side of the equation adds up to 30. I end up with 5x equals 30, which tells me that x is equal to 6. Now I can figure out what y is by taking x equals 6 and popping it back into my equations. It doesn't matter which one. I can pop it back into the top one or the bottom one, but from there I can solve for y. I'm just going to choose the bottom equation because it looks easier. And if I solve for y, I'll get y is equal to negative 2. And again, we end up with the same solution as we did in the other two videos. All right, that's it.